The selection of wire size for electrical service is influenced by several key factors. These include the load demand, which is the total amount of current required by the building or premises. Secondly, the distance that the wire must span from the power source, such as a transformer, to the service entrance of the building is important. Thirdly, voltage drop, which is the reduction in voltage along the length of the wire, must be within acceptable limits to ensure proper operation of electrical equipment. For a 200 amp service, power companies often utilize 4/0 American wire gauge aluminum wire. This conductor size has a cross-sectional area of approximately 211.6 square millimeters and possesses an ampacity suitable for handling currents up to 230 amps, based on common installation conditions and insulation types. Another option for 200 amp service is 2/0 American wire gauge aluminum wire. While not mentioned earlier, it's important to consider this as a viable alternative. However, it is important to note that switching from 4/0 American wire gauge aluminum to 1/0 American wire gauge aluminum wire for a 200 amp service isn't generally recommended by industry standards or best practices. The 1/0 American wire gauge aluminum wire has a smaller cross-sectional area, around 167.8 square millimeters, and a lower ampacity, potentially rated for only 150 amps depending on temperature rating, installation, and application, so it may not safely handle the full 200 amps. For a 320 amp service, 4/0 American wire gauge aluminum wire is commonly used. This conductor size can adequately handle currents up to around 230 amps to 260 amps depending on the temperature rating, installation, and application, which might seem insufficient for a 320 amp service. However, in many service entrance applications, the load is not continuous at 320 amps, and the wire is protected by appropriately sized overcurrent protection. Another conductor size suitable for 320 amp service is 3/0 American wire gauge aluminum wire. This wire has a cross-sectional area of approximately 266.8 square millimeters, offering a higher ampacity suitable for handling currents exceeding 300 amps, typically around 280 amps to 300 amps depending on the specific installation conditions. The National Electrical Code provides guidelines and recommendations for conductor sizes in various applications. For a 200 amp service, the National Electrical Code typically recommends a minimum of 2/0 American wire gauge aluminum wire. For a 320 amp service, the National Electrical Code suggests using a minimum of 3/0 American wire gauge aluminum wire or larger, depending on specific factors and calculations. When determining the appropriate conductor size for an electrical service, it's crucial to consult a qualified electrician. A skilled electrician can accurately assess the load demand of the building, taking into account all electrical appliances, lighting, and equipment. They will also carefully measure the distance from the power source to the service entrance, as longer distances can lead to greater voltage drop. The electrician will perform voltage drop calculations to ensure that the selected wire size can deliver adequate voltage to all parts of the building, even under heavy load conditions. These calculations ensure that the wire size complies with safety regulations and industry standards, preventing overheating, voltage drop issues, and potential fire hazards. The electrician's expertise ensures the electrical system operates safely and reliably for years to come. The ampacity ratings mentioned are general guidelines and can vary based on factors such as the insulation type of the wire, the ambient temperature, and the installation method. Always consult the National Electrical Code or local electrical codes for specific ampacity values and rating factors. Also note that in certain circumstances, parallel conductors may be used to achieve the required ampacity for service. For example, 2 sets of smaller conductors could be run in parallel instead of one larger conductor. This is more common in larger services such as 400 amp or larger. It is vital that all parallel runs are of the same length, material, and terminate in the same manner, according to the NEC. When considering wire size, remember that using a wire size smaller than what is required can lead to overheating, voltage drop, and potentially fire hazards. It is always best to err on the side of caution and use a larger wire size if there is any doubt. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or service upgrades. They will be able to assess your specific needs and recommend the appropriate wire sizes and other electrical components for your situation. The installation must adhere to the latest edition of the National Electrical Code and any local amendments or regulations. Additionally, it is important to consider the environmental conditions in the area, such as temperature and humidity, as these factors can affect the performance and lifespan of electrical conductors. In areas with high temperatures, derriting of conductors may be necessary to prevent overheating. Similarly, in areas with high humidity, it is important to use conductors with appropriate insulation to prevent corrosion. The choice of conductor material, whether aluminum or copper, also plays a role in determining the appropriate wire size. Aluminum conductors are generally less expensive than copper conductors, but they have a lower conductivity. This means that for a given opacity, an aluminum conductor will need to be larger than a copper conductor. In many residential applications, aluminum conductors are commonly used for service entrance conductors due to their cost-effectiveness. However, it is important to ensure that all connections to aluminum conductors are made with compatible connectors and that proper antioxidant compounds are used to prevent corrosion. Copper conductors are often preferred for branch circuits and smaller wiring applications due to their higher conductivity and ease of termination. Ultimately, the selection of wire size and conductor material should be based on a comprehensive assessment of the electrical load, environmental conditions, and applicable codes and standards. Consulting with a qualified electrician is essential to ensure that the electrical system is safe, reliable, and compliant with all relevant regulations. When specifying wire sizes, it is crucial to use the correct terminology and designations. The American wire gauge system is the standard for specifying wire sizes in North America. The gauge number indicates the diameter of the wire, with smaller numbers indicating larger wires. For example, a 4/0 American wire gauge wire is larger than a 2/0 American wire gauge wire. It is also important to specify the conductor material, such as aluminum or copper, and the insulation type, such as THHN or XHHW. These designations provide important information about the wire's properties and suitability for different applications. In addition to wire size and conductor material, it is also important to consider the type of wiring method used. Common wiring methods include conduit, cable, and direct burial. Each wiring method has its own set of requirements and limitations, and it is important to select the appropriate wiring method for the specific application. For example, in areas where the wiring is exposed to physical damage, conduit is often used to provide protection. In residential applications, non-metallic sheath cable, also known as Romex, is commonly used for branch circuits. Direct burial wiring is used for underground installations such as landscape lighting or irrigation systems. The choice of wiring method can also affect the ampacity of the conductors. When conductors are installed in conduit or cable, they may be subject to dirting factors due to heat buildup. It is important to consult the National Electrical Code for specific dirting requirements based on the wiring method and the number of conductors in a raceway or cable. Furthermore, it is essential to ensure that all electrical connections are made properly and that all equipment is grounded correctly. Improperly made connections can lead to overheating, voltage drop, and even electrical fires. Grounding is essential for protecting against electrical shock and ensuring the proper operation of overcurrent protection devices. All electrical equipment should be grounded in accordance with the National Electrical Code and local electrical codes. Grounding conductors should be sized appropriately and connected to a grounding electrode system, such as a ground rod or a metal water pipe. The grounding electrode system should be properly installed and maintained to ensure its effectiveness. Regular inspections of the electrical system are also important for identifying potential problems and ensuring continued safety and reliability. Inspections should be performed by a qualified electrician and should include a visual examination of all wiring, connections and equipment. The electrician should also perform tests to verify the proper operation of current protection devices and grounding systems. Any identified problems should be corrected promptly to prevent further damage or safety hazards. When making changes or additions to an existing electrical system, it is important to obtain the necessary permits and inspections from the local authorities. This ensures that the work is performed in accordance with applicable codes and standards and that the electrical system remains safe and compliant. Working with a qualified electrician who is familiar with local codes and permitting requirements is essential for ensuring a successful and compliant electrical installation. Finally, it is important to remember that electricity can be dangerous and that working with electrical systems should only be performed by qualified individuals. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to perform the work. Attempting to perform electrical work without proper training and experience can lead to serious injury or even death. Always prioritize safety when working with electricity and follow all applicable codes and standards. The information provided in this narration is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or service upgrades.